from section 2.3, rates of change, velocity. Slope is the derivative of f of x. It's a function that gives the slope of the graph at any point along the function f of x. Rate of change is the derivative, f prime of x. It's a function that gives the instantaneous rate of change of f of x. The average rate of change, abbreviated AROC, is the slope of the secant line between 2 points. It finds the rate of change over a time interval. The secant line can be seen in the graph below. It's the blue line connecting the 2 points, and it is calculated by taking f of b minus f of a divided by b minus a. Given the concentration, C, in milligrams per milliliter of a drug of a patient's bloodstream is monitored over a 10-minute interval for 2 hours, where T is measured in minutes, shown in the table below. We are going to find the average rate of change for the concentration for the following time intervals, between 0 and 20, and between 100 and 110. So to find the average rate of change, we need the change in concentration divided by the change in time. So we need to find the concentration at time equals 20 and time equals 0. 17 minus 0 is a change in concentration. 20 minus 0 is a change in time. So the average rate of change from 0 to 20 minutes is increasing by 0.8 milligrams per milliliter per minute. Similarly, we'll do the same thing between 100 and 110. So we find the points in our table, calculate the delta C, calculate the delta T. The average rate of change from 100 to 110 minutes, it's decreasing by 1 milligram per milliliter per minute. The average velocity of an object that is moving in a straight line can be calculated by doing the change in distance divided by the change in time. For example, the height, h in feet, of a free-falling object at time t, where t is measured in seconds, is given by the function h of t equals negative 16t squared plus 108. We're going to find the average velocity of the object from 1 to 2, and again from 2 to 3. To find delta h, we need to find h of 2 and subtract h of 1. So we plug 2 and 1 into our original height functions. Plug that back into our fraction, and we get the average velocity is negative 48 feet per second. We're going to do the same process between 2 and 3 seconds. H of 3 minus h of 2 divided by 3 minus 2. We plug in 3 and 2 into our original equation, we get 36 and 1/16. Plug it into our fraction, with the average velocity is negative 80 feet per second. Instantaneous velocities happens at a specific time, not over an interval. The instantaneous velocity is calculated by taking the limit of the average velocity as x approaches 0. So to find the instantaneous velocity, we just take the limit of our difference quotient as delta x goes to 0. Find the velocity of a ball drop at t equals 1.75 seconds. And we're given the height function h of t equals negative 16t squared plus 100. When it says find the velocity, we're going to take the derivative of h of t, and we're going to use our velocity shortcuts, our power rule. H prime of t equals negative 32t. We're going to plug in the specific time value to find the instantaneous velocity. So when we plug in 1.5, we get negative 56, which means the velocity of the ball is negative 56 feet per second. When it comes to velocity, If we have a positive velocity, it's an upward motion. A negative velocity is a downward motion. The absolute value of velocity is the speed of the object. For our final example, we have t = 0. A diver jumps from a diving board that is 12 feet high with an initial velocity of 16 feet per second. The diver's position is given by the function h of t equals negative 16t squared plus 16t plus 12. For the first question, when does the diver hit the water? Whenever we're looking for a when, that means we're solving for a time. And the time is going to be when the height is 0, which means h of t equals 0, since we're looking for when the diver hits the water. We plug in 0 for h of t. We have a quadratic function, so I'm going to solve this guy by factoring. So I pull out a common factor of -4, factor the remaining quadratic, and I'm going to get two answers, t equals -1/2 and t equals 3/2. Only one of these answers is possible. We cannot have a negative time value, so that means the diver will hit the water when t equals 1.5 seconds. The second question is, what is the diver's velocity at impact? So velocity at the impact means to find h prime of t and to plug in t equals 1.5 seconds. We found that from the previous part A. That's when the diver hit the water. So h prime of t, I'm going to use my power rule, -32t plus 16, plug in 1.5. The velocity of the diver at impact is -32 feet per second.